Hello everyone, and thank you very much for joining me again. Today we continue our discussion about the Spring Start Here book with chapter 9, where we dig more into using the Spring web scopes. So we have already gone through the whole Spring context of an application in the first part of the book, now where we have discussed in detail about how context works and dependency injection, as well as a chapter on aspect-oriented programming. Now we will complete everything we knew about the context with what happens especially for web applications. So you will see that for web applications we have 3 more scopes that we can define for the beans, and these scopes are specifically managed as having the HTTP request as a point of reference. This is the reason why you only find this kind of scopes for web applications, because it is a way to specify the lifetime of a bean, referring it to the HTTP request. So see, especially for web applications, and only for web application, and I mean here non-reactive web applications, we have the possibility of choosing from these 3 different scopes, which are called the request scope, the session scope, and the application scope. And this is what we discussed today. Now, previously we have discussed, and we know that the majority of all the applications actually, so including those which are not necessarily web-based, can define beans of type singleton and prototype. We also know that the singleton one is the default scope, so whether you don't specify the scope, then it will be a singleton. And we also have discussed that the singleton, we have to be aware that it's not referring to the singleton pattern, so let's not make a confusion. Okay, singleton here means one instance with a given identifier, because if you have followed me through the first part of the book, I have already proven that in the same Spring context you can have more than one instance of the same type, as long as you give it a different identifier, okay, which is not the case when we talk about the singleton pattern. So very often beginners confuse these two, because of course they have the same name, so it's very easy to make a confusion. Let's go basically with our three new scopes now, in case you want a refresher on the singleton and prototype. You can anytime go back to one of the previous episodes, so you can see that again. And of course, reading the book, I have also some other playlists where I discuss more this in detail. So today we will specifically focus on the 3 new scopes: the request, the session, and the application. So hi everyone, happy to hear your messages. By the way, you have a live chat. You can put your messages in the live chat, questions or comments or whatever you want there, and I try to keep an eye on that throughout our session here. WebSockets with Spring Boot not in this playlist, but you have a different playlist where you find that already on this channel. So just change the playlist and you will find the video on the Spring Reactive playlist where I discuss WebSockets as well. With that being said, continuing now, I think it's time to discuss about the requests. So let's then take them one by one to understand what they are, when would you need to use them, what is the difference between these 3. So when we talk about the request scope, remember that in a non-reactive application we have this approach which is called a thread per request. Why is it called a thread per request? because for each HTTP request, a new thread is created, and that thread serves only that specific request. So that means that, and of course I'm going also back to what we have discussed in the previous chapter, no, because we have discussed also in chapter 7 and 8 about how Spring MVC works. So this is not the first time when we discuss that. You already know we have that dispatcher servlet, and that dispatcher servlet is the one delegating the management to a web context where we can have these three kinds of beans. So whenever the dispatcher servlet creates a new thread for a given HTTP request, if there are beans marked as request scoped, they will be created, and these beans will only exist for that particular thread, which identifies that particular HTTP request. So that's why it's called a request scope, because those beans, those instances that will be created, they will be created for that particular request, will be accessible only in that particular thread serving that request, and will cease to exist when the response go back. So at the end of the request, when the thread also ceases to exist. I don't mean by that necessarily ceasing to exist from the memory, because you know that the memory in Java is managed separately by the garbage collector. So in terms of the memory management, there can be situations where even though a specific bean that has been created for the request is no longer used, it's still there because the garbage collector didn't yet go through the memory to clean up what needs to be cleaned up. Remember that the garbage collector doesn't remove instantaneously everything. So what that means is that you don't have to think about the end of the lifetime of a bean in a Spring application as necessarily the end of the lifetime of that instance in the memory, because in the memory it can always be there for a little longer. But whenever we discuss about the ending of the existence of a given bean, we refer here specifically to how Spring defines this life cycle. So in terms of the request scoped, these beans, they exist specifically for a given request, and they can be accessed only from the thread of that particular request, and they cease to exist after that. You might have multiple request scoped beans of the same type in the same thread, and you might have multiple request scoped beans on different threads. A thread can only access the request beans for that particular request. Then we have the session scoped beans. Whenever we talk about web applications, we can discuss as well about a session. In this case, when we think about a session, we think particularly about what we name a server-side session. Because when we think at a larger scope of the web applications about sessions, we can have client-side sessions, which are something different, more complicated, and which we'll not address now, and server-side sessions, which is, you can imagine it as a memory zone somewhere on the server side, identified with a given client, which exists throughout multiple requests of that same client. So you have one browser instance sending requests to the server. Each request is independent, it is stateless, and all the request code beans will independently be managed for each of the requests. But then for this client, there will be also a part of memory allocated which we call the session on the server side. This is identified with that particular client, and multiple requests will be able to access that zone, and that is a shared memory zone for multiple requests. When we create a session scope bin, we know that this bin will be stored as part of the shared zone, which means it will be accessible by multiple requests sent by the same client. Each client has its own session, so that means that a different client will not be able to access bins that have been created for another client. We will discuss about this more in detail a little bit later in this chapter, but just to make it so the session scope is a little bit more wider than the request scope is. So a question from Deepak: is that session picked from cookies? The cookie is one of the ways the client can identify with the session created on the server side. There are different ways in which the client can identify its session side memory zone, but pay attention, the cookie is a file which exists on the client side, while when we talk about the session is something that exists on the server side. So in the case of a cookie usage, the cookie is only used to store an identifier that identifies the memory zone for that particular client. And then of course the third of the web scopes that we discuss is the application scope, which is pretty often misunderstood because it's very similar to the singleton scope. The only difference, and we will talk about it also later, is that the application scope can be used only within web applications. Normally we say it creates only one instance per web application context, but that means that it's only a context that's managed by the servlet dispatch, because that's basically where things start. That's where we know that a new request is created, a new session is created whether that's needed, and that's where basically we also manage the entire web application. So the application scope bin, as you will see, is very similar with a singleton bin because it exists throughout the entire context of an application, but it's particular only on the web applications, and it's also, we consider it to be taking the requests, the HTTP requests, as point of references. We can say the application scope bin is a bin accessible by all the HTTP requests regardless of the client that sent the HTTP request. And a question: so in a stateless session policy context, if I use the session scope annotation on a bin, will I be able to access it from the context? So I'm not sure if I understand the question. When we use session scope, first of all, that's not stateless anymore. Stateless is a HTTP request. That means that what we create and make it available only on the HTTP request can only be accessed by that HTTP request. So in case you have multiple nodes of the application, you don't care whether the request, it goes first from out of multiple requests, one it goes to a node and the other goes to another node, because there is nothing stored in the application itself. When you use session scope, there is something stored in that shared memory zone. So in this case, you have a stateful application already. There is no usage of a session scope bin without making your application stateful. which means that in this case, it matters whether you go to a node or the other. In other words, it's more difficult to make your application scaling horizontally. I hope that answers the question. Okay, let's start with the first bean. I always like my diagrams from the book because they usually allow to easily visualize how things work. No, so in this case we have Richard here, who is our user. No, so what Richard does is they use their browser to send the HTTP requests. No, in particular here on the diagram we can see two HTTP requests sent one after the other. So I have named them easily HTTP request 1 and HTTP request 2. So what happens here is that in the Spring application context, in this case, because we talk about a web application, is the web application context as well, we have this bean. It's a class name, we call it login processor. At the moment you don't have to focus on the class name, it's just a normal bean. Okay, so what happens here is that when HTTP request 1 gets to the Spring context, because it's a new request, a new bean will be created, and that's why you can see here an identifier. You know this format. No, it's what you see, whether you use the default to string implementation to print an instance in the console. Now is this hexa representing the memory address of this bean, which allows us to identify whether an instance is the same with another. So in this case it creates this that ends in F9. Okay, and then for the second one, because it's a different request, another bean will be created. Now I've tried to also put them in different positions. Now you can see here the hexa identifier is different as well, because being a request scoped bean, every time a new request happens, a new instance will be created. Okay, so in a stateless session policy context, okay, I thought I saw another message, but it's not there. Good, then we can continue. So that's basically what happens with this. Is I can tell you, out of the three, the most used of them is because it allows you, it gives you something totally different than what exists in a normal Spring context. A singleton bean, it allows you to have one instance per application. A prototype bean, it allows you to, every time you dependency inject it anywhere, to have a different instance. But a request bean is totally different. It's nor like the prototype and nor like the singleton, because it exists throughout the entire flow of the HTTP request. So imagine you have an application with a layered format, which we have used before. You have the controller, you have a service, maybe you have a repository, you might have different other components. No, and whenever the request enters your application, you see it entering through the controller. You know that there is somewhere a dispatcher servlet that makes the call, but it always enters through a controller. And then you have an entire chain of methods calling throughout up to the end when it returns the controller, and then it returns back with an object that we know it becomes the HTTP response. So if you would have a singleton, then this singleton bean would be accessible from this whole flow, but then any other request in parallel would see the same singleton bean. It's basically one instance per whole application. Multiple requests would be able to see the same instance. If you'd have a prototype, when the controller would inject that, it will be a different instance than if a repository would inject that, even if it's the same HTTP request. But if you made it particularly to be a request scoped, and they have used this type of scope that is particular to web applications and uses the HTTP request as a point of reference, then the difference is that this one now will be accessible throughout your whole request. That bean will be the same, and only for this request. If another request goes in parallel and requests the same type of bean, there will be a particular instance for that request. So this HTTP request scoped bean allows you to create an instance that belongs to a particular request, and you can access that through whatever component, whatever class, as long as it's from the same thread execution that was created by a specific request. So that's how a request scope is different to other scopes that we have studied previously, and others that we will study. And there are some facts here, so that I say key aspects that you need to remember. So Spring creates a new instance, okay, for each HTTP request from any client. Even if you have multiple requests from the same client, there will still be different instances. In this case, we need to understand that for this Spring will create a lot of instances. No, the number will be large because every request will create another instance of that. But at the same time, it will be stateless. Only one request can use an instance of request scope bean, meaning only that thread, only that particular thread will be able to access the bean itself. Okay, here I try to give you an example. If you want to follow me with it, we are also going, and I have here, you can see the diagram that you have already seen previously, now demonstrating the Spring MVC work. No, so you have here one going, the request is intercepted by the servlet container Tomcat in our diagram here. It could be Jetty or another implementation. You know that Tomcat is also the default with Spring Boot. Then it goes into the dispatcher servlet. Here is where the web application context is managed from. Here is where now whatever has been defined as an application context bean will be created as a request application context bean will be created. So now all those beans throughout the entire execution, and here the login control is part of our example, only one class, but you know, then further here you might have services, you might have managers, you might have whatever. It comes back, and then this is where the request beans cease to exist. And this is a simple web application. Now what we did here, we created a login controller, okay, and in this login controller I think I am injecting at some point. Now let's see exactly where we try to make it a request. I will skip through the whole definition because this is something we discussed in chapter 7 and 8 as well. No, so here we simply create a very simple demonstrative login, meaning what? You click on a button here, no, and you get into a controller method annotated with post mapping, and then we have a very simple, now only didactic example where you print out you have logged in or your login failed based on some static credentials. No, so it's only a theoretical example here. And we are using here time leaf, as you can see. Now we are using time leaf, which is something we discussed in chapter 8 we saw how can you use time leaf to define this. So this is where things become interesting. No, login controller, this is a singleton. So you saw the login controller is defined as @controller. So that, and from the fact that we haven't used any scope annotation, the default in any Spring application, regardless of it is a web application or not, is a singleton. No, so that makes this login controller a singleton bean. But then what we want to do is to define this login processor and make it a request scoped bean. So that's what we do. You see, we go here and we use the request scope annotation, which is again particular to web applications, to define this login processor as a request scope bean, making its instances now unique per request. How does this make it different now? Every request will refer to a different instance. There will not be, even if you will have a single login controller throughout the whole application, every request will have a different instance of the class login processor, and that different instance will be accessible only from that request. The request will not be able to see instances of other requests, even if they are concurrently running. So by putting the request scope now, you can see here I make these attributes, username and password. I made them store here the username and password. A very dummy implementation here. See, it's not a real login. Okay, this is not that this doesn't teach you how to make a login. Okay, it's created particularly simple to teach you how request scope works. Okay, so that's why it only like tries to see if the username is Natalie and the password is password. That's the only thing it does. But how it does that? Okay, it stores the values into the attributes of the class. So what happens here is that every request, even if we use different values, if different credentials, to put them like that, it will work because every request will have different instances. Okay, so every time I call, a new login processor will be created, a new instance for each request, and even if they are in parallel, it will still work because there will still be more instances, each one of each of it per request. So that's basically how it's working. Okay, and you have an example here now of login successful and login failed. Then I hope that if the request scope is clear, let's go a little bit deeper and discuss the session scope and try to compare it with the others that we already know. I see a question in the chat. So I want a Spring App. A Spring App will get MySQL credentials from its primary DB, and I want to connect to that DB. How to connect to that DB and how to persist data? I have multiple DB configurations. So I would suggest you keep that question, and we will answer it here in chapter 12, because it wouldn't like make sense now to discuss it. This is in this playlist we particularly discussed the Spring Start Here book from top to bottom. So just keep that question and join me later when we discuss chapter 12 with data sources, because it's related to chapter 12. And now we will focus our discussion on chapter 9. Okay, I will definitely explain how to do that in chapter 12. Okay, so going back to the session, remember that we had earlier the situation where the same client, no, I'm going up to show you, So it's Richard, is the same Richard. Richard sends two different requests, but even if Richard is the same person using the same browser, the beans, the instances are different because they are marked as request scoped. Now, when we talk about the session scope, the difference is that being Richard the same, even if he sends multiple requests, the bean will be the same, because this login user management service, again, another class that we can imagine has been annotated as a session bean this time. It creates a session and stores that bean in the session for Richard's client application. So Richard's web browser will execute a first request, let's say, that will create also the session, that zone, that shared memory zone, which will now be accessible by all Richard's requests. Multiple requests from Richard will now be able to access the same instance that has been defined as a session scope. And that's why you can see here that the identifier is the same, because by that we want to mark that for Richard, everything that has been defined as a session throughout its session existence will be the same instance. Remember that sessions also expire at some point. This expiration time is defined by the server side. So if, say, Richard's session is made to expire in 30 minutes of inactivity, if Richard will reuse the browser after the session has expired, a new session will be created, and then a new instance will be created as well for Richard. However, whenever any other client, like say this girl Daniela, she sends its own request, then for her a different instance will be created. Daniela will be able to access only her instance, this one with 823, and even if they concurrently use the same server instance, and that means that also the bean created for Richard will be there somewhere in the memory, Richard will be the only one being able to access its instance, while Daniela will only be able to access its their instance. So Richard will be able to access the same instance that belongs to him throughout the session, regardless of the request, as long as it's a request made from the same client, while Daniela the same, she will only be able to access her bean throughout her session, throughout all the requests she's creating from the bean. So this is a comparison now between how request scope beans and session scope beans work, if you want to see them in parallel. No, in case of the request scope bean, Richard sends two requests, the bean will be different, while here Richard sends two requests, they will access the same bean, but of course a different user will have a different bean throughout their session. What's the reason that sometimes we use hash map and sometimes concurrent hash map in Spring bean scope? So there is, depending on the Spring bean scope, you might have multiple threads accessing the same instance. Well, this is exactly what can happen in the case of a session bean, no? So take a look here. HTTP request 1 and HTTP request 2, they will be able to access the same instance of any bean that has been defined as a session scope, because both of them are created by Richard. So request 1 and request 2 will have access to the same bean. These two requests can also be concurrent. No one says that they should be one after the other. You can have two or even more requests that happen at the same time from the same browser. No, they might be created by JavaScript libraries behind the scenes and so on. So in that case, all of these requests will be concurrent and they will have access to the same instance. Being concurrent, and we know already that each request creates a different thread, because that's a thread per request model. So this means that you will have multiple concurrent threads that potentially will access the same instance to modify it. If you are into this situation, then you would potentially want to synchronize somehow the access to that specific bean. Concurrent hash map is one of the solutions and not necessarily the best, but that's thread management, and we discussed this in the fundamentals playlist. You can find that there. Anyway, point is, in this case, you might want to synchronize the access somehow, because you might have multiple threads at the same time accessing the same bean, whether it's by using a concurrent collection such as concurrent hash map, copy on write array list, copy on write array set, or you could simply just use the synchronized modifier, or maybe you want to use a semaphore or a cyclic barrier. That's pretty much depending on what you are implementing, and there is no best or worst solution. But that's the reason why sometimes you need to address concurrency. And then of course we have some facts also about the session beans. Let's see them. So the session scope bean instances are kept for the entire HTTP session. Okay, that's an important thing. No, unlike the request scope beans that they existed for request and then they could be dismissed and collected by the garbage collector, here, if a bean has been created and the session has been made to stay there for 1 hour, then that bean will be there for 1 hour, and the garbage collector will not be able to remove it from the memory. Being long-term might make things a little bit trickier in regards to the memory management. You have to be more careful with how many these kinds of beans you create, because they are more likely to generate an out of memory error if you are not attentive enough with them. Then multiple requests can share the session scope bean instance, which again is important. You have my explanation also here. No, I generally recommend you see if this can be avoided and keep synchronization only as a last resort. So whenever you have this scenario, you might need to synchronize. That's exactly what you, Deepak, was asking me earlier. You were asking me about the synchronization, and my recommend, of course, if you really need to modify the session concurrently, then synchronization is necessary. I can't say which technique is best. I can't say that concurrent hash map is necessarily the best technique here, because it depends on what exactly you are implementing. But definitely synchronization is needed. But again, if possible, if you can keep it only non-synchronized to avoid performance deficits, then my recommendation is apply the synchronization only if you can, and try to create a design that, even if you use a session scope, avoids, if possible, the need for synchronization. But of course, that's not always possible, no? And then the session scope beans are a way to share data among requests by keeping the data on the server side. This is important because once you have used a server-side session, so once you have used a session scope bean, which also makes use of a server-side session, your application is not stateless anymore. It's stateful, which makes the horizontal scalability more problematic. You will not be able to have multiple nodes to give more power to serve more requests. Or if you do that, you need to use different techniques such as sticky sessions or session copying. We don't discuss about them in this book. It's totally out of the purpose of this book. Point is, be careful. If possible, if you need horizontal scalability, make sure your design avoids using statefulness, which might mean avoids using in some cases session server-side session and session scope beans in this particular case. Well, this is an example on how you do it. Use the session scope bean, and then this basically proves how it works. This code example proves how it works by keeping a user logged in. So once you authenticated, now this extends the example from up above, so that once you authenticated, being a session scope it keeps the user logged in. Again, remember, this is not an example on how to do a login. Okay, that's my Spring Security in action is for that. Okay, this is only to prove you how request scope, session scope, and application scope works. Okay, but it's a valid example that shows you how it works. Now you have the login page. When the user clicks on login button, if the credentials are valid, it creates a session bean and stores the credentials, and then it redirects to a main page. And then what happens is that when the login page is accessed once more, if this already exists, it automatically redirects it to the main page, and it doesn't ask again for a relogin. So that's what we want here. And how do we do that? Well, it's pretty easy. We have a controller that redirects to the login only if it's needed. We have the login controller that makes sure when the credentials are valid to store on the session, on a session being the values, and then we always check. So this is what happens. So this is what happens when you click the login. You will be here. If you are already logged in, then you will be here until you click logout, which deletes the session bean, basically making null the values. And this way you have a server-side session login, so keeps the user logged in. It's not a way to create a proper login. Again, it's just for you to understand the scopes, because normally you never ever store the password, at least on the server side, not even in a runtime memory zone, because then if it's in clean text it will be accessible, and never work with clear text passwords. Finally, and with this we finish today's discussion, today's chapter. We have the application scope. The application scope is simply a bean that will be accessible by any request, regardless of the client that sends it. So this bean will be created at the first access, and then anyone would just have the same one. As I was telling you, it's very similar to a singleton scope bean, but an application scope bean can only be used by a web application, and it's also takes as a point of reference the HTTP request. So the philosophy behind this is to take the HTTP request. Here, to prove it, I have created a counter of all the requests on my login page. So I'm using here a simple increment. I make it application scoped. Here, normally this should have been synchronized. Maybe now someone will trigger and ask, hey, why didn't you use an atomic integer there. I should have. The only reason in this book I haven't used that, I don't think I have, usually I don't do that, is because here we don't talk about concurrency, and I simply wanted to allow the reader focus on the application scope explanation and avoid synchronized stuff like that and so on. This being anyway again only a didactic example, is not something like resembles something you should create in a real world application. Okay, it's just for you to understand how application scope looks like. But normally, remember, if you have an application scope bean and you change something like I do here, in general you would have to synchronize the access. Here probably the best would be a re-enter and read-write lock. And then the implementation that does that, so it's basically counting every login and then displaying you the login. Okay, and these are the three web scopes. You need to be aware of them. You might get into them with smaller web applications. You will not probably find them, especially with applications that use segregation of front-end and back-end, which is something we start discussing next time in this chapter 10. No, so next time we, when we talk about chapter 10, start talking about REST services. It's very unlikely you will find this in REST services, but you need to be aware of them, and you might still find them in smaller applications and in some cases in older applications as well. I do recommend, it's part of the fundamentals, and I do recommend any Spring developer to know about this and understand how they work. In case you see them, you need to know how this works. Do you have content on concurrency on your channel? Yes, I do have. I think you should find some concurrency content, including the concurrent collections in the Java fundamentals playlist. So that's where I expect you will find. I don't have something particular on the concurrency. Maybe I should do that. Maybe I will do that in the future. Why not? But for now, I think you will only find a few videos in the Java fundamentals playlist. Friends, with that being said, I am waving goodbye. I say again, thank you very much for being here with me. Next time we discuss about REST services. So up to then, have an excellent time for study further, and hope to see you next time. Cheers.